are going to begin studying conic sections. Our study of conic sections begins with circles and parabolas. Our objectives are to be able to recognize a conic as the intersection of a plane and a double-sided cone, to write equations of circles in standard form, and to write equations of parabolas in standard form. You should have already watched the video that's an introduction to the 4 different types of conic sections. The video has nice 3D graphics, but these pictures also work quite well. So we start with a double napped cone. So we have 2 cones, one on top of the other, that meet at a vertex. So what happens is we cut the cones with a plane. Depending on how the plane cuts through the cones determines which type of shape we get. So if we have a plane that cuts through the cone and just cuts off one part of one cone at an angle, we're going to get a parabola. I'm not concerned with the angles that the other video was concerned with. I'm just concerned that you can visualize where these shapes come from. A circle is a plane that cuts perpendicular to that vertex. An ellipse is if we take that perpendicular plane and shift it just slightly, so we still cut through both sides of the cone. And a hyperbola is a more extreme flipping of the parabola, for instance. So it cuts through part of the top and part of the bottom. So far in your math careers, you've studied parabolas and circles. What we're doing with circles isn't changing much. What we do with parabolas is going to change. It's going to be a different way of thinking about parabolas than what you're used to. And I don't believe you've studied ellipses or hyperbolas, but you should be somewhat familiar with them, and we've graphed hyperbolas in different forms this year, but as we progress through the unit, you'll become more comfortable with all 4 types. Today we're going to focus on circles and parabolas. I would like you to memorize the definition of all 4 conic sections. A circle is a set of all the points xy in a plane that are equidistant from a fixed point, hk, called the center of the circle. The distance between the center and any point xy on the circle is the radius. So the important part here is that we start at the center, we have a distance away from the center that's fixed, and that's our radius. So this is easily demonstrated if you had someone standing holding a rope and someone else holding the other side of the rope, and the person on the outside walked around while the person on the inside rotated. You can very easily picture forming a circle that way. Now, the distance here, we may need to use the distance formula to find it. It may not always be given to us. You should be familiar with the standard form of the equation of a circle from geometry. So the standard form of the equation of a circle is x minus h squared plus y minus k squared equals r squared. Remember, the center is hk, so hk is the center, and r is the radius. If you need a refresher, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So for our first example, the point 1, -2 lies on the circle whose center is at -3, -5. Write the standard form of the equation of the circle. So for this example, we do need the distance formula. So either point can be x1, y1, it doesn't matter as long as we keep it consistent. So we know to start that we can fill in the center. So we can start with x now lies on the circle whose center is -3, -5. So it's the opposite, x plus 3 squared plus y plus 5 squared equals. Now we need to find the radius, and we can do that using the distance formula. So our distance will be the square root of x2, so we can use -3 minus x1, we can use 1, so minus 1 squared, plus -5 minus -2 would turn into plus 2 squared. So our distance is the square root of -4 squared plus -3 squared. So that would give us the square root of 16 plus 9, which is the square root of 25, which if we take the square root of 25, we get just 5. Now, the formula calls for r squared. So when we put it in over here, instead of writing 5, we write 25. So that is our equation of the circle. Now, example 2 asks us to sketch a circle. Now, if you look at this, it does not match the equation that we're given for the equation of a circle. So in order to make it match, we have to complete the square. Before we start completing the square, the first thing we have to do is we have to make sure our x's and y's are grouped together, and then we should move the constant to the other side. So I'm going to start with x squared minus 2x. I'm going to leave a space to complete the square, plus y squared minus 4y, leave a space to complete the square, equals 4. Half of 2 is 1. 1 squared is 1, so I'm going to add 1 to both sides. Half of 4 is 2. 2 squared is 4, so I'm going to add 4 to both sides. Now I'm going to factor. So when I factor, it's x minus, because the sign here is a minus, whatever half of the middle term was. So half of 2 is 1 squared plus y, the sign in the middle, so y minus, half of the middle term is 2 squared equals 4 plus 1 plus 4 is 9. So that means we have a center at 1, 2, and a radius of 3. So I'm going to try to graph this, but it's really tough for me to graph on this with my problems with writing, so bear with me. So my center is at 1, 2, 1, 2. And then from there, I'm going to go 3 in each direction. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. I'm going to see if my shape recognition pen will be able to track my circle. I'm going to try very hard to catch all of my points and see if it'll make it a circle. Yay! It made it a circle. Okay, so got my circle, problem solved. Next question. Find the x and y intercepts of the graph of the circle given by the equation x plus 2 squared plus y minus 1 squared equals 10. We do exactly the same thing here to find x and y intercepts that we always do to find x and y intercepts. If we're looking for the x-intercepts, we set y equal to 0 and solve. If we're looking for the y-intercepts, we set x equal to 0 and solve. So we can start by saying x plus 2 squared x plus 2 squared plus 0 minus 1 squared equals 10. So x plus 2 squared plus 1 equals 10. Subtract 1. X plus 2 squared equals 9. When I take the square root, I get x plus 2 equals plus or minus 3. At this point, I would set up two equations. I would do x plus 2 equals 3. X plus 2 equals negative 3. When I subtract 2 from each equation, I get x equals 1 and x equals negative 5. So I have two x-intercepts. The x-intercepts are 1, 0 and negative 5, 0. Now we can go back and find the y-intercepts. So to find the y-intercepts, we do the same thing, only we make x 0. So we'll have 0 plus 2 squared plus y minus 1 squared equals 10. So 4 plus y minus 1 squared equals 10. Subtract the 4. Y minus 1 squared equals 6. At this point, we are going to take the square root of each side. So we get y minus 1 equals plus or minus the square root of 6. So y equals 1 plus or minus root 6. So we should probably rewrite these as ordered pairs, which would be 0, 1 plus root 6, and 0, 1 minus root 6. So there are our x and y intercepts. So that's the gist of circles. Circles are probably the most basic of all of the conic sections. Next are parabolas. You're very familiar with a parabola. However, we're going to take what you know about parabolas and completely change it around. So the first way we're going to change it is we're going to start with the definition. So once again, I would like you to memorize this definition. A parabola is the set of all points x, y in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus, not on the line. The midpoint between the focus and the directrix is the vertex, and the line passing through the focus and the vertex is the axis of the parabola. Okay, so there's a lot of stuff going on there, but if we look at this picture over here, it identifies what everything is. So we have our parabola, which we're used to. This parabola is the set of all points that are the same distance from the focus to the directrix. So in this case, you could imagine this one as you have one person who's stuck at a specific point. You've got another person who can walk up and down this line. Now, unlike the circle where there's one fixed rope, here, as they move, they can change the size of their ropes, but their ropes are always going to be the same size. So from here to here will be the same as from there to there. Okay, if we were to go closer, from here to here would be the same as from there to there. Okay, so that's the way this works. If I want to go way up here and then straight back down, those two distances should be the same. So that's how you can visualize how this is formed. Now from here, there's some other terminology that was introduced. So the line of symmetry. We're used to calling it the line of symmetry. Well, now we can also call it the axis of the parabola. Okay, so the line of symmetry can also be called the axis. The ellipse and hyperbola, which we're going to study next, also have axes, so it's good to get in the habit of thinking of the line of symmetry as the axis. Now we have the vertex, the vertex is what we're used to. Now the vertex is special because the vertex is right in line with the focus directrix and it's on the axis. The axis is perpendicular to the directrix and it goes through the focus and the vertex. As we continue to study parabolas, there's a few more things that we need to talk about. P is the directed distance from the vertex. Now, this is going to help us find our new equation. So the standard form of the equation of a parabola. So if it's a vertical axis, meaning it's going up and down, that means that we're going to have our parabola opening this way. So it's going to be our regular y equals something x squared. Okay. So if we have a vertical axis, so if it's a vertical axis, then the directrix is horizontal. Okay. And if we have a horizontal axis, then the directrix is going to be vertical. Okay, that's an important thing to think about as we write these lines. So a vertical axis means our parabola is opening upwards or downwards, but that means that we're going to have a horizontal directrix. If we have a horizontal axis, then that means that we have a vertical directrix. So now we're really flipping things around from what you're used to because we can have parabolas that open sideways. We've never studied these types of parabolas before because they're not functions. However, see, they would fail the vertical line test. However, we can now study them using this new formula. So now, taking a look at this formula, we have, I'm going to clear all this out. Taking a look at this formula, we have, it's very, very similar, only x minus h squared means that it's opening vertically. If x is squared, it's opening up or down. If it's y minus k squared, that's when it opens sideways. Equals 4p times y minus k or times x minus h. And so remember, h K is going to be your vertex. Okay. So just like we had the center was the opposite here, the same thing happens for the vertex. It's going to be the opposite. P is the distance from the vertex to the focus or the vertex to the directrix. So let's take a look at an example here. So here's another picture I found of a horizontal axis of symmetry and what that would look like. So we would have the vertical directrix, horizontal axis of symmetry, a parabola that is not a function but will fit this equation here. Find the standard equation of the parabola with a vertex at 3, 2 and a focus at 1, 2. When doing these questions, the best thing we can do is sketch a picture so we know what we're looking at. So if I have a vertex at 3, 2, 1, 2, 3, 1, 2. So there's my vertex, and a focus at 1, 2. So 1, 1, 2. Now, the parabola always opens around the focus. So the parabola is going to open sideways to the left. Because it's sideways to the left, we know that our p-value is going to be negative. Okay, because left is the negative direction. Just like if our parabola were opening down, our p-value would be negative. So we're using the horizontal equation. So that equation is y minus k squared equals 4p times x minus h. So we can substitute some things into our equation. So we have y minus k, so that would be the 2 because it's the y coordinate of the vertex. Y minus 2 squared equals 4p, we'll get back to p in a minute, times x minus 3 because that's the x coordinate of the vertex. Now to find p, we have to find the distance between our vertex and our focus. So if the vertex is at 3, 2 and the focus is at 1, 2, that means p is 2. And because it's opening in the negative direction, we can use negative 2. So when we substitute that in, we get y minus 2 squared equals negative 8 times x minus 3. And that would be the equation of our parabola. Our next equation asks us to find the focus of the parabola given by y equals negative 1/6 times the quantity x squared plus 4x minus 2. Now, this equation doesn't match either equation on the previous page, so before we can do anything else, we have to put it into standard form. So since x is our squared term, we're going to rewrite it as x plus h squared equals 4p times y minus k squared. That's the form we're going to try to put it in. So the first thing we need to do is we need to isolate our trinomial by multiplying both sides by negative 6. So negative 6y equals x squared plus 4x minus 2. Now, in order to keep going, we have to complete the square. So I'm going to move the positive 2 to the other side. So I get negative 6y plus 2 equals x squared plus 4x. Half of 4 is 2. 2 squared is 4, so I add 4 to both sides. So now my equation is negative 6y plus 6 equals x plus 2 squared. In order to continue to make this match what our equation needs to look like, remember it's 4p times y minus k. So we have to factor the 6 out of both terms. So we'll get negative 6 times y minus 1 equals x plus 2 squared. If we want, we can rewrite this as x plus 2 equals negative 6 times y minus 1. So now it exactly matches what's on our other page. Oh, I forgot my squared. X plus 2 squared. Now, from here, we're being asked to find the focus. So in order to find the focus, there's a couple things we need to find. We need to find P, and we also need to find where our vertex is. So the vertex is easier than P for right now. So the vertex is located at negative 2, positive 1. Okay, so that's where our vertex is located. So to find our p-value, we take negative 6 and we set that equal to 4p. So p would be equal to -3/2. So if we take a look at where these would be on a coordinate plane, -2, 1. So -2, 1 would be about here. And it's x squared, so it's opening up or down. And because our p-value is negative, it tells us it's opening down. So if we start at the vertex and go down 1.5, we end up at the point -2, -1/2. So that is our focus, -2, -1/2. If you were asked to find the equation of the directrix, you would start at 1 and go up 1.5. Our directrix would be up here. 1 plus 1.5 would be 2.5. And since this is a horizontal line, it would be y equals 2.5, or 5/2, either way. Example 6. Find the standard form of the equation of the parabola with vertex 1, 3 and focus 1, 5. Before watching me do this example, please pause the video and try it on your own. Then watch my explanation to make sure you got the right answer. So, once again, the first thing I'm going to do is I'm going to sketch a picture so I can visualize what's going on here. So I have a parabola with a vertex at 1, 3, so over 1, up 3, 1, 2, 3. There's my vertex, and the focus is at 1, 5, so it's up here. Parabolas open around the focus. Because the parabola is facing up, I know I'm going to use the form x minus h squared equals 4p times y minus k. So h and k is the vertex, and I know the vertex is 1, 3, so I can just plug in those points. So I have x minus 1 squared equals 4p times y minus 3. Now, p is the distance from the vertex to the focus, and in this case it's 2. So when I substitute 2 into the equation, my final answer is x minus 1 squared equals 8 times y minus 3. And that is our equation. Parabolas have a reflective property. What that means is that if we have a tangent line, which is the line that passes through a point on the parabola but does not cross the parabola, so we discussed tangent lines in chapter 11. So right here's our tangent line to the parabola because it touches at that one point, but that's it. So back to the definition. So the tangent line to a parabola at point P makes equal angles with the following two lines. The line passing through P and the focus, the line passing through P and the axis of the parabola. So what this is saying is that if we start at the focus and we go out to that point of tangency P, this angle will be the same as the angle where the tangent line, so here, passes through the axis. So this angle here. Now, what's important about this is an isosceles triangle. So these angles are the same. Since those angles are the same, it means these distances are going to be the same. So we can call this, we'll call this one D1, and we'll call this one D2. Okay, so from the focus to our point P, we'll call that D2. From the focus here to our point down here, we'll call that D1. Okay, so we have our 2 points. So that tells us that D1 has to equal D2. So example 7 wants us to find the tangent line of a point on a parabola. So find the equation of the tangent line to the parabola given by y equals x squared at the point 1, 1. So if we sketch a picture, y equals x squared, the point 1, 1. So we have here, here, and then it's going to keep going up like this kind of. So there's my parabola. I'm really not good at connecting points on this thing. And then I'm going to have a tangent line. So the tangent line is going to go through. Okay, so there's a completed version of these notes online. For the better diagram, you're probably going to want to look there. But there's a rough idea of what's going on. Okay, so if we pretend that it's this picture, we can do that too. So this will be the point 1, 1. Here's where it crosses the axis. Here's our 0, 0 point. Okay, so that's what's going on over here. And like I said, there's a much, much better diagram in the completed notes version if you need it. So back to our picture here. So we're writing the equation of a tangent line. So y equals mx plus b. Okay, so that's what we're looking for. So we know to write the equation of a line, we need a slope and we need a point. Now, the way the book does this is before you're taught how to do derivatives to find the slope formula. Now that we've been taught how to do derivatives, we actually don't have to do it the way the book did it or the way the other version of the completed notes did it, because we know how to find the slope at one point. Previously, what we had to do if we didn't know the slope was we would have to use all of this information here to find this point right here. Then we would have 2 points, then we could find the equation of the line. Well, we don't need to do that. I'm going to do that anyway in a minute so you can see how it's done, but this is the awesome part of what we learned last chapter, is that we don't have to do all of the crazy math that I'm going to show you. So instead, let's find the slope equation. So if you think back, we had the formula, the limit as h approaches 0, f of x plus h minus f of x over h. So we're going to do the limit as h approaches 0 of x plus h squared minus x squared over h. When we FOIL this out, it's the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared over h. Canceling those, we can now rewrite it as the limit as h approaches 0 of h times 2x plus h over h. Cancel h, take the limit, so the slope formula is 2x. Now the x value in question is at the point 1, 1, so that means that to find our slope, we would do 2 times 1, so our slope is 2. Now we have a point and a slope, we can write our tangent line. So we can do y minus y1, so y minus 1 equals 2 times x minus 1. So y minus 1 equals 2x minus 2, which means our equation is y equals 2x minus 1. Okay. So that's actually the calculus method of doing this, of finding the slope at one specific point. What I'll show you now is how to do it using algebra instead. So I'm going to try to recreate my diagram, which was not so great in the first place. So once again, if you require a better visual, please look at the online completed notes version to get a better picture. This one's better than the last one, but it's still not that great. So from the focus down here to the y-intercept, which we'll call B, that is our D1. From the focus to the point over here, okay, that's our D2. Now once again, remember my diagram's very bad, so they don't look the same, but they are. So the first thing we have to do is we know that our equation's x squared equals 4py. You forgot about that, huh? So right now, the y doesn't have a coefficient. It's just y equals x squared, which means 4p equals 1. So that means p is 1/4. So that means the location of our focus is the point 0, 1/4. Now, remember, we also have a point that goes through 1, 1. That's a 1. So, from here to here, that's a distance. We can just use the distance formula. Oh, hey, look at that. That formula's coming back. Using the distance formula, I get d equals a square root of 1 minus 0 squared plus 1 minus 1/4 squared. So d is the square root of 1 squared plus 3/4 squared. So d is the square root of, when I square 3/4, it's going to be 9/16. So my common denominator, I'll turn 1 into 16/16. So that gives me the square root of 25/16, which is 5/4. So that means my distance is 5/4. Now, my b right here, my y-intercept, since that's going down, it's technically a negative b. So my d2 is going to be 1/4 plus a negative b. Now, we just discovered that the distance is 5/4. And remember, those two distances have to be the same. So it tells us that 5/4 is equal to 1/4 minus b. So that means that negative b is 1, so b is -1. Now, the next thing we would do, so we have our points. We have a point at 1, 1. We also have a point at 0, -1. So we would need to find the slope between these 2 points. So our slope is y2 minus y1 over x2 minus x1. So from here, we can do -1 minus 1 over 0 minus 1. So that means that our slope is 2. So our equation is y equals 2x. Our y-intercept was -1, 2x minus 1. So that's two completely different ways to do the problem, but both of them get the same answer. So you can choose either method you like to try the next example. So, like you did before, pause the video, try the example, then watch the video to see if you got the correct answer. So for this example, we have x squared equals 2y. So that means 2 has to equal 4p. Divide by 4, p is 1/2. And we have our very, very, very bad drawing again. There's my parabola, my point at 1/2. And we're talking about the point at 3, 9/2. So that's like over there. So we're going to go there. And then from there, we're also going to go down there somewhere. We're going to pretend those are straight lines. So our focus is located at the point 0, 1/2. So this distance here, we can call that d1, is going to be 1/2 minus b. So now to find b, we have to do the distance formula between the points 0, 1/2 and 3, 9/2. So when we do the distance formula here, we get d is equal to the square root of 3 minus 0 squared plus 9/2 minus 1/2 squared. When we do that math, the answer ends up being 5. So now we go back and we do 1/2 minus b equals 5. Solving for b, we get b equals -9/2. So we have our 2 points. We have the point 3, 9/2. We also have the point 0, -9/2. So our next step is to find the slope between these 2 points. So 9/2 plus 9/2, because minus to minus would be negative, over 3. So 9 plus 9 is 18 over 2 divided by 3. So that would be 9 over 3, which is 3. So that means our slope is 3. So our equation is y equals 3x minus 9/2. If you did this using calculus, you should have gotten the same thing. Oh, one tricky thing, let me point out, if you did this using calculus, you would have to isolate y first before you found your slope formula. So when you isolate y first, the equation is x squared equals 2y. So you would have to divide by 2. So you get y equals 1/2 x squared. When you take the derivative, okay, and figure out what your slope formula is, When you use the derivative to find your slope formula, you find out that your slope formula is m equals x. So in this case, your slope would be 3, and now we found that we can find the y-intercept and then go from there. So that's how you would do it. Just make sure if you're using the calculus version, you rewrite it so y is isolated first. Then you can find the slope formula, and the slope formula would be just plain x. Since our x value is 3, the slope is 3, and then we can find the y-intercept and go from there. Actually, you don't even need to. I guess if you're doing it this way, I'll be nice, and you could just do y. The point was 9/2, so y minus 9/2 equals 3 times x minus 3. I'd probably even be nice and let you leave it in point slope form if you chose to do it the derivative method. So, this has been a lot of information about circles and parabolas. I know that it has probably changed a lot about the way you think about parabolas and brought back some memories from geometry of the distance formula and circles and all of those fun things. If you have questions, please feel free to reach out to me. Please complete the homework assignment from the textbook and put it in the online submission. So do it, take a picture of it, upload it online when you finish it.